Alright, today we're going to talk about how to integrate exponential functions. Well, e to the x is pretty easy to integrate if you remember the derivative of e to the x is e to the x. And so it's pretty natural that the antiderivative of e to the x is e to the x. And since we've been talking about u substitution, so what if I have e to a function? Well, then I can just use u substitution for my function. So I could use u will be my exponent, and so the antiderivative of e to the u is e to the u plus c. Alright, number one, find the antiderivative of e to the 3x plus 1 dx. And again, when you see e and it's not e to the x, then I want you to make u your exponent. So we're going to let u equal 3x plus 1. That means du is equal to 3 times dx, or dx is equal to du over 3. And so we can go ahead and substitute in. So I have the antiderivative of e to the u times du over 3. And let's go ahead and move that 3 to the front. And so when I take the antiderivative, I get 1/3 e to the u plus c. And so now I can substitute back in 1/3 e to the 3x plus 1 plus c. Alright, number 2, find the antiderivative of 5x times e to the negative x squared. Again, when you see e, I want you to make your exponent your u. So u is equal to negative x squared. That means du is negative 2x times dx. So dx is equal to du over negative 2x. So we can go ahead and substitute in the antiderivative of 5x e to the u times du over negative 2x. Well, I hope you notice your x's can cancel. And let's move this negative 2 underneath the 5, so it becomes negative 5/2. And that'll be our coefficient. So we have negative 5 over 2 e to the u du. And so now we can take our antiderivative. And our coefficient is negative 5/2 e to the u plus c. And so now we can substitute back in. Negative 5/2 e to the negative x squared plus c. Alright, number 3, find the antiderivative of e to the tangent over cosine squared of x. And again, I tell you that e is going to be your u. So let's have u equal tangent of x. That means du is equal to, so derivative of tangent is secant squared times dx. So dx is equal to du over secant squared x. And it's a little hard to see where secant squared is located. So if you remember in pre-cal, you learned that secant is 1 over cosine. So my cosine right here really, if I bring it up, becomes secant squared. So let's go ahead and do that. And so now we have du over secant squared x. So now these two can cancel. And so I have the antiderivative of e to the u du. And so that is going to be e to the u plus c, which is e to the tangent of x plus c. All right, number 4, the acceleration of a particle is moving along a straight line given by a is equal to 10 times e to the 2t. Write an expression for the velocity, which is the antiderivative of acceleration, in terms of time t if velocity is 5 when t is 0. When they give you a coordinate, that means they want you to solve for c. So let's first take our antiderivative. So we're going to take the antiderivative of our acceleration, which is a to the 10 e to the, go ahead and color code it, 2t. And so since our independent variable is t, we'll do dt. And so with u substitution, u is going to be 2t du. Du is going to be 2 times dt. So dt is du divided by 2. So we can go ahead and plug in. And if you notice, these will cancel. And this just turns into a 5. So I have the antiderivative of 5e to the u du. And that's going to be equal to 5e to the 2x plus c. Alright, so your antiderivative is representing your velocity. So I probably should have a v here. This is your velocity function. We're finding the velocity. And so here is the general solution for velocity. Well, we want to find the particular solution. So when v is 5, we want to find what c is going to be. So if v is going to be 5, and t is 0, we're solving for our c. So we have 5 is equal to 5e to the 0, because this is 0. E to the 0 is 1, so 5 times 1 plus c, so c is actually equal to, in this case, 0. So our velocity function is 5e to the 2t. And now we're done.